this video is on heating and cooling curves. So on your notes you have two blank diagrams that you are going to first draw your heating curve and then you're going to draw your cooling curve. So we're going to do the heating curve of water first. Now this is water, and water has specific melting points and boiling points, like we talked about in the previous video. And on a heating curve, we have our axes. Our y-axis is going to be temperature in degrees Celsius, and our x-axis is energy absorbed or time. Usually time, but you can also have energy absorbed. Now during a heating curve, we're going to have a part where we're starting as a solid and it's being heated, so we're increasing in temperature and time. Then we're going to get to a point where our temperature starts to stay constant, and this is a phase change from solid to liquid. Then our temperature is going to start to increase again, and this is while we are at the phase of a liquid, and our time and temperature are going to increase. Then we get to a constant temperature and just time goes by, no change in temperature, and that's our second phase change. And then our temperature is going to increase yet again along with time, and that is where we're going to heat our gas. So a couple of things we want to include on here, first of which is where our three phases are. Well, we know this is water, and it's going to start out as a solid, which is ice, and that's along this line here. Then we say we get to 0, and at 0 degrees, that's where that phase coexists, the phase change happens, so both solid and liquid are going to be here, so we can't write both. Then we're going to start to heat again between 0 and 100 degrees Celsius. Here's where we have our liquid water. And then after 100 degrees Celsius and up, this is where we're going to have gas or steam. Now, on these phase changes, because we're going from solid to liquid, this is melting. And the phase change between liquid and gas along this entire line, this is evaporation. The other things that we need to know about is the change in potential energy and the change in kinetic energy. Potential energy is looking at the energy where we are either spreading our molecules apart or bringing our molecules closer together. As we're spreading our molecules further apart, we are changing the energy because it is growing, it is increasing in our energy because of the interactions between the molecules with each other. And so at our phase changes, we're going to have changes in potential energy. And that's change in is the delta sign, PE for potential energy. Now at our different phases, we're increasing the temperature. Temperature and kinetic energy are directly proportional. So as I increase the temperature, I'm also going to change and increase my kinetic energy. So that's our changes in kinetic energy. And that's along the sloped line for all of these. And that means that my molecules here are increasing the amount of motion that they have, their movement. So solid getting heated means my molecules are starting from not moving at all, and they're starting to vibrate a little bit until they get to their phase change. Now they're going to vibrate and start to move further apart along the phase change till they get here, and then they're going to start to vibrate more and more because liquid molecules are moving around more than solid molecules. As I get up all the way to 100 degrees Celsius, now the molecules are going to spread further apart. Then I get to my gas molecules, and they're just going to start at that space of difference between them, but move around really, really fast. And so you want to be able to plot the changes in energy and these different phases and phase changes. Now a cooling curve, this is just going to go from high temperature to low temperature. So if I'm starting above 100 degrees Celsius, this is going to be a gas. Now my flat line is my phase change. And from gas, I'm going to go to a liquid. And from liquid, phase change to a solid. My phase change from gas to liquid is going to be condensing. And my phase change from liquid to solid is going to be freezing. Okay. Again, my axes are the same. Temperature, energy released or time. Again, I want to put in my changes in potential energy and changes in kinetic energy, Along the sloped lines, those are going to be changes in kinetic energy. And along my phase change, those are changes in potential energy. Now the difference between cooling curve and heating curve from before, cooling curve, we are decreasing in temperature. As we decrease in temperature, we are having an exothermic reactions. So exothermic phase changes, going from gas to liquid, liquid to solid, and so forth. Your heating curve was endothermic. So you want to label both heating curve endothermic and then our cooling curve exothermic. Now you've been hearing words of temperature and heat, so what's really the difference? Can we interchange them? Well, temperature is the average kinetic energy of all the molecules in a sample. So it is how fast they're moving. Absolute zero is 0 degrees or 0 Kelvin. We don't use degrees. And at 0 Kelvin, we abbreviate Kelvin with a K, that's equal to negative 273 degrees Celsius. At this point, we believe that all motion stops. The molecules just stay exactly how they are and they don't even vibrate the slightest bit. Now, because 0 Kelvin is a temperature reading, and anything above that, our molecules start moving, that is how we have the relationship between kinetic energy and temperature. Heat is the form of energy that flows between two samples of matter because of their differences in temperature. So our heat flows from hot to cold, or high temperatures to low temperatures. And that is the form of energy moving between two different samples. So this all relates back to the law of conservation of energy, which is our first law of thermodynamics. Thermodynamics is the study of heat and energy. Our first law of thermodynamics states that energy cannot be created nor destroyed, but it can be converted or transferred. So those are your phase changes, or a hot piece of metal being put into cold water. That heat energy is going to be transferred. So for example, potential energy can be converted to kinetic energy. Potential energy, also known as latent heat energy, is the energy contained in a sample due to the attractive forces between molecules. So that's looking at the different phases, them coming apart or coming closer together. Kinetic energy is the energy of motion, or how fast molecules move. That's why in our phase diagram, that occurred along the slope line, because we're increasing in temperatures, our molecules are moving more and more, or we're decreasing in temperatures and our molecules are slowing down.